Okay, now we're just going to do a quick review of domain and range, things that we learned in Algebra 2. First, we're going to look at the domain and range for this continuous graph. We know it's continuous because if I draw the line, I don't have to pick up my pencil. When we look at domain, we're going to look at all valid x values. So we're going to be looking at the x-axis and what values of x are valid for that function. When I read and write domain, I'm going to read and write it from the left to the right, just as I would read a book or a novel or write a book or a novel. When I'm looking at writing the domain for this graph, I'm going to look at this arrow and I see that it is pointing to the negative side of the x-axis, which is to the negative infinity. At the same time, if I see up here that my arrow is going up and toward the positive x, I know that I'm going to a positive infinity on this side. Now we're going to talk about the range of the function, and with range we know that it's all valid y values, so we're going to look at the y-axis and see what all the valid y values are. If I read or write range, I'm going to read and write range from the bottom of my graph to the top. In other words, I want my lowest number, I'm going to write my lowest number first, and my uppermost number, or my most positive number, I'm going to write second. For this graph, when we are looking at the range, I see this arrow going down this way toward the negative y, which would make it go toward a negative infinity. Okay, now we're going to look at this side of the graph. And here I see that I'm going to my positive y, or what's known as my positive infinity, because my arrow is going up. Okay, the first thing that we're going to talk about is set notation, and set notation reads like a sentence with math symbols. So we're going to replace the words of the sentence with math symbols. Okay, now we're just going to write the domain and range using set notation that we learned last year. So hopefully we remember that we are going to start with a set notation starts with this. It's a French bracket, and because we're writing domain, we're going to be writing the x values first. So I'm going to say x, and set notation we're going to use this symbol e, meaning the element of, and we're going to use all real numbers. And the reason that we're using all real numbers is because we're going all the way from a negative infinity to infinity, so we're not stopping anywhere on the x-axis. We're using all possible values of x. Therefore, on the range would be very similar. The only difference on the range, we are still going from a negative y to a positive y because, again, of these arrows on the end, we're going from this negative infinity to a positive infinity. We're going to look just like our domain and say y is the element of all real numbers. And there's our domain and range for our continuous function. Here we're just reminding you that when we write domain and range in set notation, we are writing it as symbols that stand for an English sentence. So here we see that x is the element of all real numbers and y is the element of all real numbers. Okay, now we're going to do interval notation, and in interval notation, it is only used to describe a real number situation. So we're going to talk about a discrete situation later, but a real number situation would be a continuous function. So we need to remember that when we're using interval notation, we better be looking at a continuous graph. When writing interval notation, we can use square brackets or parentheses. A square bracket indicates that a number is included in the range. Instead of having an arrow like this, what would happen is that I would have more of a closed dot. It would look something like this, and that would be what would indicate that I have a number that's included, and I would use this square dot, this square bracket. A parenthesis is also used to say that a number is excluded in the domain and range. And when I see something like that on a graph, what happens, instead of having an arrow on the end of my line segment indicating that it goes on forever, I would have an open dot at the end. And this open dot, if I have that at the end, I would use a parenthesis indicating that the number is not included in my domain or range. Parentheses are also used if I have an infinity sign. So here, because I do have these arrows and I know that my domain is going from a negative infinity to an infinity, and my range is going from a negative infinity to infinity, I would also use a parenthesis in terms of infinity, because you can never touch infinity. If I wrote the domain of this function in interval notation, then I would use parenthesis because it is going again from a negative infinity to an infinity. And if I wrote the range for this function, it would also go from a negative infinity to infinity. Again, we're using parentheses because you can never touch infinity. This is an example of a discrete graph. The reason I know it's discrete is because when I am writing this graph or drawing this graph, I have to pick up my pencil and kind of skip to the next part of the graph. So it is a discrete graph. In this case, the discrete graph starts at the origin or at 0, 0. All the numbers are positive. They're all in this first quadrant. From a domain and range perspective, I see that this graph goes from the numbers 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, almost like a linear function, except it's a discrete linear function because it doesn't have any decimal places, it's only whole numbers. In this case, we need to review our inequality signs, and that is because we don't have arrows on the ends of this function. What we do is we have solid dots. If I have solid dots, that is when we are going to use the less than and equal to and the greater than or equal to sign. Now, when would I use just the less than and the greater than? Well, that would be when I have, instead of those closed dots that we see on our graph, it would be when I have the open dots. And why are inequality signs going to be important when we're talking about this graph? Well, it's because on this side I don't go on forever. I start here at 0, 0, and I end here at 4, 4. So my x and my y is going to be somewhere between a 0 and a 4. Okay, when writing the domain and range for a discrete graph, I am usually limiting my number set. In other words, I don't have all real numbers. I don't have decimals, and in this case, I actually don't have negative numbers. I have numbers from 0, 0 again to 4, 4. And when we're writing our domain and range, we want to limit the set to the numbers that it could contain. So if I look here, these very in here would be my whole number set. Whole numbers are my natural numbers or my counting numbers 1, 2, 3, 4, 5, and when we say whole numbers we include the 0. And we will see that instead of using an R for all real numbers, I have to use this N for natural whole numbers. Okay, now we're going to write the domain and range for this discrete graph. When I'm writing the discrete domain and range, I actually have to use set notation, and that is because, again, I'm picking up my pencil, and interval notation would include all decimal places, and we don't have any. So I'm going to use set notation. So we're going to do domain. If I'm doing a set notation, I have to do the wiggly squiggly. I'm going to set x as the element of, instead of real numbers, I'm going to make it more specific because I am only having positive numbers that start from 0 and go up to 4. So I'm going to do all natural numbers such that, that's what that line means, such that. I see that I start from a 0 on the x, and I'm going to go 1, 2, 3, 4 to a 4 on the x. So I would say 0 is less than or equal to x is less than or equal to 4, and I would do a close. Notice I'm writing left to right. I'm writing my lowest number first to highest number. Please do this. Do not put the 4 first, or that's something that you would get taken off for at this point in your math career. All right, the next thing I'm going to do then is write my range. And my range, instead of saying x, I'll say y is the element of all natural numbers such that, again, if I look at my y, it's going from a 0 to a 4. And so I would say 0 is less than or equal to y is less than or equal to 4. And there would be my set notation for my discrete graph. And please remember that you cannot use interval notation if you are on a discrete graph. This ends the review of domain and range, and now you're going to go on and do 5 practice problems to see what you remember from Algebra 2.